So let us take a look at our first question on the board. We have that a gas occupies a volume of 0.0035 meter cube at a pressure of 1.2 times 10 raised to the power of 5 Pascal and a temperature of 290 Kelvin. Calculate the number of moles of the gas. Take the gas constant R to be 8.314 joule per mole. So if we are to look at this question now, we are to collect our data. We have that our pressure, which is P, is given to us as 1.2 times 10 raised to the power of 5 Pascal, which is still the same thing as 120,000 Pascal. Then we have our volume, which is V, to be 0.0035 meter cube. Then we're given temperature, our temperature, which is T, is equals to 290 Kelvin. Then we're given the gas constant, which is R, to be equal to 8.314 joule per mole, and we are asked to find N, which is the number of moles of the gas. So if we are to use our relationship where we have PV is equals to nRT, by the time we make N the subject formula, we should have PV over RT. So by the time we substitute our value now, we should have 120,000 times 0.0035 to be divided by our R, which is 8.314 times our temperature, which is 290. So by the time we multiply at the numerator there, we should be left with 420. And when we multiply this, we should have 2,411.06. And by the time we divide, the value of our N should be 0.174. So we can now say, therefore, the number of moles of the gas, which is N, equal to 0.174 moles. So that is the answer to the first question.